Hello everyone, welcome to my course, and this course is about routing redistribution, which is really a daunting task or a difficult task to solve all the time for the students. So if you are in a CCNA, definitely I think you might see it a little bit of it, but if you are studying CCNP or CCIE, definitely you're gonna have a lot of crazy route redistribution course. So in this lab, we're gonna tackle the first lab, which I will redistribute static routes. So if I go in R1 now, and by the way, I mean, if I give you a little bit of concept, the route redistribution, it means if I give you a little bit information about the route redistribution and how it works. Route redistribution is when you have one routing protocol, and you want to have and you have another routing protocol running, or maybe you have routes that the router is using the static. So if you are running, for example, RIP in one way, and you in these two routers, for example, if you are running RIP, but here this guy has a default route on this one, I mean to reach to R5, and R5 has a static route pointing to R7, then you need to redistribute your static that you have in here. So you have so R2 will have reachability on R3. On R5. On the route is behind on R5. So that is what it is. It's just interacting the routes between the different domain. For example, static is another domain, and Eigrp is another domain, RIP is another domain. So that means redistribution is to make reachability and a router is that is running between two different protocols. So that's in a nutshell. So let me go and do the lab. For example, if I go to R5 now, I have Eigrp running, Eigrp neighbors. I have a neighbor between R2 and R5. And if I go to R2, I have a neighbor between R6 and R5. So that means like this link right here, I mean this portion of the network, they are running Eigrp. These other ones, they are not running anything, so I have not configured anything. But R2, R6 and R5, they are running Eigrp. And R7, it is just nothing is just connected behind. So there is nothing, no routers or anything that is connected to R7. So I just use a default route because it has only one single point exit. So I use the default route to reach. I will use the default route to reach R5 and anything beyond R5. And R5 will have a static routing, static pointing to R7, which will allow to reach networks or loopback networks that is connected to R7. So let us solve this task now. So I am on R5. So if I say show IP route now, Eigrp, I have networks between R1, between R6 and R2, which is 26 network right here. And I have another network, which is between R5, not R5, because otherwise it's directly connected. Yeah, so I have this one, and I have another network that is connected behind R6. Okay, right now, let me go to R7 and configure show IP route. So R7 has a connected routes, but it doesn't have any reachability to any other one, to R5. It doesn't have any reachability to R5 or to R2 or R6 either. So let me configure R7, because if I try to ping R5, 5.5.5.5, the loopback of R5, it doesn't have a reachability because there is nothing is on the routing table. There is nothing talking about 5.5.5 in the routing table. So you can only reach what you have in your routing table. So what I will do, I will just give a default route in this one. IB route 0.0.0.0.0 and 0. Everything I have should go to R2, R5 IP address, which is 10.1.1.57.5. So if I say show IP interface brief on R5, we have this interface, gigabyte 1/0 facing to this one, facing to R7. So R7 now, I will give 10.1.57.5. So that is the default route of R7. So now the traffic needs to come back to this. So now if I want to try to ping 555, I can reach R5 because I have a default route to R5. But if I want to reach to R2, I cannot reach to R2 because R5 has a R2 loopback. Oh, I have not. Okay, let me go to R2 and then network give to R2. So now advertise loopback on R2. So now R5 has a loopback of R2, for example, loopback of R2. So if R7 try to reach loopback in R5, in R2, it cannot reach. R7 cannot reach. Oh, sorry, did I say 7? I said 2.2.2, because 7 is directly connected on R7. But it's okay, cool. So now it reaches on R7 because it has a default route. Okay, and what else it does cannot reach? Oh, let me clear IB route star. Okay, good. So now, yeah, because it can reach on R2. The reason why, because R5 has the routes on R2, so on R2, so it can reach on R2. So if I try that, it can reach on this network here, 10.1.2.25.2 on R2. So if I try R7, if it can reach this interface, which is 10.1.25.2, if we can reach it, 10.1.25.2, it can reach it, but it can definitely will not reach on R6. Let us try if it can reach on R6. Ping. Yeah, it cannot reach. You see, because the reason it reaches on R5, on R2 route is because R5 has a direct connection to R2, and R2, and also when R5 updates or passes the traffic to R2 has any network that R2 has, R2 has the routing table on it. So that means like R7 has a default route. Okay, so when it has this default route to R5, so R7 will have a reachability, anything connected to R5, plus any traffic, the traffic that comes from R7 goes to the traffic. I'm no good with the pen. Let me try if I can. This pen, this big pen. if, let me try, I'm not good with the pen, guys, yeah. Okay, any and become a okay, so anything leaves, this one has a default route. This one, oh, I'm really bad for it. I mean, I will use when I study very well on this guy. I don't know how to write on this one. Sorry, guys. Okay, any traffic that leaves from here to R5, so R7 will have a reachability on R5, and at the same time, because it has a default route, and at the same time it will have a reachability on R2, because R2 and R5 they have a direct connection. So if R2 passes a traffic to R1, that traffic that comes from if R7 sends a traffic to R5 and R5 passes that traffic to R2, for example, like pinging from R7 to R2, then R2 has a routing table on it. I mean, it is directly connected to R2, so R2 can give the traffic the answer back, or it can reply the traffic by allowing to ping. But anything after behind R2 is just where the problem is. So how can we do it? How can we deal with it? Now, when we said R7 to ping, it says this. So how the reason we can, the reason that we can solve, or how we can solve this situation, we go to R5 first. Okay, we are not even talking about only this network. We want to reach any network that R7, for example. Now if I go to R2, let me try if I can reach to ping 7.7.7. It cannot reach. So R2 cannot reach. Even R5, let me try if it can reach 7.7.7.7. It cannot reach, because this guy has a default route, so it can reach all the way to 2 because it has a default route. So to solve this problem, we come back to R5. We come back to R5 and we go under routing process. No, let me point as a static first. So I would say static. Then I want to reach. I want to send any. I want to reach. The network is behind this guy. For example, I want to reach this guy. So I will have a multiple static. So I will say, for example, 0.0.0.0. Anything that I have, and no, I will give it. I will give a specific IP address. So IP route, for example, 7.7.7.7.0 255.255.255.0. What is this, guys? Show run interface loopback 0. So it has a okay. And then I wanna tell him like to go through 57.7. So now if I go to R5 and I say you wanna ping, before it couldn't ping. Before it didn't ping. You see 777 before it didn't ping, but now let me try if it can ping, because it can ping because I have a default. I have a static route pointing on this guy. So I have to create multiple routers. Multiple static default, multiple static interests, so I can reach any network connected to R7, Or what I can do, I can even do the default route. So I can get this guy off and then say route, IB route. Then I can say 7.7. So I will do one shot. Then I can tell 10.1.57.7. So now any network that R7 has in his network, the R7 is like 77.7.7, 7.7.7, 79, 78. It will reach. This guy will reach. So for example, now 7 will reach 7. Oh, look what I did. Sorry. Because what I did was I did a wrong default route. Look, it was a 10 here. So now let me go back. Now 7 is it can reach 7. It can reach 77. It can reach 78. And it can reach 79. So you can do one shot, or you can do multiple entries. For example, you can do one shot by pointing one default route like this that we have done this one before, or you can have a multiple entries, multiple. For example, now you can say like IB route 7.7 like this, 7.7.7.0, and then 77, and then 78, and then 79. So you will have a multiple entries, or you will have this one. Okay, now if you want to R2, for example, to ping 7.7.7.7, it cannot ping because it doesn't have a traffic to come back. But R7, it has a default route. It can ping. So how can we solve it? One-way reachability, because this guy can go and can reach R2, but R2 cannot come back and reach it. So the way we solve is, as you can see, R2 cannot reach back, but R7 can reach. So it's a one-way reachability. From here all the way to here, R7 can go and can reach and can go through R5 and can reach R2, but R2 cannot come back and see and have a reachability. I mean, and R2 cannot have a reachability on to R7. So how can we solve? The one way we can solve is we go to R5, we go to because it is running Eigrp 1, and then we say redistribute static. By the time we do redistribute static, R2 should start region on this guy. Region on this guy. You see, before it didn't reach it, but now it is reaching. And now let us try if we can reach 7.7 again. So what about 7.8? What about 7.9? So now the reachability or two-way reachability comes back. So that is what they call static route. So you go under the routing process that you are running. For example, in this case is Eigrp. I advertised into under Eigrp process, I redistributed static, but under OSPF is the same, under RIP is the same. It's all the same. So now if I want to reach 66, that which I could not see, I could not reach from R7, I could not reach 666. When I said 666, I had unreachable. That you see is unreachable. ICMP unreachable. Now, because because this one cannot reach. The reason why, because and it needs another let me check if R2 has the routing table. Yeah, it has, and this is the advertisement that the default route. So R2, does it have 26? in R5. Let me check it. Yeah, it has a 26. Okay, cool. Okay. So yeah, so R6, can he ping R7? Yeah, it can ping, but R7 cannot ping. So what we're gonna know now, that's R6 have. Does it advertise? Yeah, no, it doesn't, because the reason why R6 cannot and R7 cannot reach R6, because R6 is not advertising anything called 666. So if we go now and just change it to 66, even it doesn't have a 66. So what are you gonna do? 66.66.66. Now the reachability is stored. So now we solve two-way reachability, and I hope it has been informative for you, and see you on the next lecture.